Okay. Okay, so this is going to be dry run number 1 for AIML40. And I know there's a couple things that are still spinning up as part of the deployment, just kind of because it takes so long for some of these experiments to run, but I'm going to go ahead and do this anyway. I don't think it'll cause too much of a problem, to be honest, so here we go. All right, so welcome everyone. Good evening, good morning, wherever you are, and thank you for coming to Microsoft Ignite the Tour. We'll be talking today about taking your models to the next level when it comes to Azure Machine Learning and Azure Machine Learning Services. As we go through the talk, there's going to be a lot of different things that we'll have on the screen. I'll be talking through some different aspects of our services that we have available, as well as showing off some code. Everything you see, including some further readings, is all available through these links. I'll have this slide at the end as well, so you can take a picture then. So don't worry if you missed that. All right, so before we get deep into machine learning, let's do an overall recap of the applications and the developments in machine learning, starting with a lot of the developments in e-commerce, and also computer vision, and let's say forecasting and predictive maintenance. Autonomous agents is also becoming much more like of a thing, and so is reinforcement learning. And then, of course, language understanding, which is the one that we're going to be spending most of the time today talking about. Now, each of these areas that are being transformed over the past few years by developments in machine learning landscape. To really understand how much that they've been transformed, though, if we're to go through each of these, it would just take the whole session's time. So what we're going to do is really just focus on just one of my favorite parts of this whole kind of topic or subtopic of topics is language understanding. And so we're going to do a deep dive into a couple of the different scenarios and how they've impacted, or they've been impacted by machine learning and deep learning. So keep in mind everything we show you today for all the companies we're talking about and all the technologies that we're using, they can all be applied to any of these domains that we were just showing. Language understanding is just one of the areas that we're going to be seeing a lot of trends in, and sort of the one that we wanted to kind of touch on the most today. So language understanding, there's a lot of areas that kind of we are starting now to see things show up in language understanding, and one of them is in ambient computing. And so these are devices like the HoloLens or the Microsoft Cortana, but we're starting to see those things show up. We're also starting to see it in automation and scaling. So how do we reduce the amount of time that it takes to do very manual tasks, whether that's customers optimizing a customer support workflow or classifying medical or maybe even legal documents in a way that reduces the amount of time that a given human in the loop would have to spend, particularly very expensive humans. That's a very big thing for a lot of different industries. And then the last one is one of my personal favorites, is using text and natural language processing and the developments in machine learning to unlock unstructured data. For example, in a customer resource management system, the textual information that's linked to all those numerical values that you put in when we build our customer churn models, and all of these different models that has been previously ignored, now it can be incorporated into our machine learning models, really in a way, models to really have a better impact on how we interact with just the world around us in general. So we're going to tie this all together today with a company very near and dear to my heart, Talen Traders. It's a global retail company. They want to expand into new retail markets, and they're evaluating the clothing space. And initially, they have really no knowledge of machine learning or natural language processing. So they want to start from something very simple and then build their expertise to create more advanced models and move on from there. What we're going to do is we'll walk you along the path that Talen Traders will likely take when developing their text-based analytics services. So for this simplest solution, we would what we decided to sort of tackle is we're going to use text analytics, which is Azure cognitive services that they enable you to enter in your own text and just get automatically get back metadata and features and just nice information, structured information that you can do something with it. So Talen Traders can use that to have some sort of insight into how people are interacting with their restaurants or whatever it is that they may have. So let's have a look at how that works. So I'm over here in Microsoft Azure's sort of text analytics portion of their cognitive services. And this is really pretty nice because immediately I can just come right in here and drop in my own text and start to get some results back. So I want to find out what kind of sentiment are we expecting from this type of feedback that we might be getting perhaps online through our website or wherever we're getting this feedback. This is the stuff that we're learning customers feel about our what are our services, the things that we're offering them. So what can we extract out of this feedback that's actually something we can do something with? So let's say I just bought some polka dot pants from a store in London, and I put this in here as my feedback. If I drop this text in here and hit analyze, we'll see over here, it goes out there, it hits the API in the backend API on our services, and it returns some results for you to immediately, do something with, because it's all right here in structured data. We got it here as JSON too, but we can just give you a high level understanding of what's going on here. We can see that it's pulled out the key phrases of polka dot pants as well as London store. Overall, it's giving a positive sentiment analysis of 85%, which is pretty good. And then it's also able to extract out London in terms of a location, which is kind of neat because if you look up here in the text, I put in London, but it was lowercase. So, I wasn't explicitly pointing out London as a city, but it still detected that, So I think that's something worth pointing out. And then, it's also provided this other stuff here as far as a link that takes me right to London. So if I'm not really sure what that named entity that came up in my sentiment analysis is, it gives me this jumping point to go ahead and take a look at that. But more importantly, I now can drop. I have a process for dropping in some data, dropping in some things, and understanding at least the sentiment from that, and then I can do some things with that afterwards using the JSON. Okay, so let's pop back over. Okay, so we talked about the demo text. So for instance, what if, let's talk about some other aspects of this. The food was very fresh and flavorsome. The service was very attentive. Would go back to this restaurant if visiting London again. Now, the aspect that I want to talk about here is that's a lot of feedback, and we want good feedback. But this has so many things in here that it's hard to really understand, first of all, if it truly is good in terms of the sentiment. And also, what if there's aspects that sort of, one thing has a good sentiment and one thing has a bad sentiment. When we have this much feedback in sort of one little blob of text, it's a little bit more complex to get through the understanding what's going on here. So we can see very quickly that the language review was written in, at least from this, that it is able to pull out some things like key words such as service and food and restaurant. Again, that the location is London. And we got that the sentiment that the overall experience was good. And based on the average of many of these such reviews, I might want to look at what's going on here and see if I can apply that to any other remaining chains. And so what I want to sort of hit on here and come back to and really, remind everyone is that the reason why I want to bring these up is that they're super easy and they're super simple. So it's a way for you to get in there and get your hands on something. The APIs are easy to implement because they of the simple REST calls that they're using. And being that they're REST APIs, there's a common way to implement, and you can get started with all of them for free simply by going to one place and one website. And you don't have to hunt around to like find all these other resources. It's also very flexible. We've got a breadth of intelligence and knowledge APIs, so developers will be able to find what intelligent features that they need. And then importantly, they all work on whatever language, whatever framework or platform developers choose. So developers can integrate these into their apps, whether that's iOS or Android or Windows, using their own tools they know and love, such as Python or Node.js. It's also tested. You're sort of tapping into the collective knowledge of what we already have done and learned here at Microsoft. And so, we're tapping into that ever-growing collection of powerful AI algorithms developed by experts, not only at Microsoft, but around the world in lots of different places. And developers can take that, the trust and the quality of the expertise that's already built in, from their field even, and begin to leverage those. And Azure machine learning and these capabilities are used across many Microsoft first-party products such as Cortana and Bing and Skype and lots of others. So these are things that we use ourselves, and now we're just sort of using economies of scale to pass that on and let y'all take some of that same stuff that we've learned, as well as our ability to provide you with compute kind of on demand and really, see what you can build. So if you're interested in getting started with these cognitive services that help you capture and process the text, have a look at this documentation. It's a great place to start. There's my buddy Seth there on that picture. He knows all kinds of smart stuff about all of this, specifically to cognitive services. So check that out. Now, we're going to dig into the next step of how we go from these cognitive services to building something a little bit more custom. And why do we need that? Well, we talked about the cognitive services in the past few minutes and how amazing they are and how they, really kind of enable you to get started with your business scenario without even needing to write a single line of code. However, what I've noticed is that there still tends to be this, the Pareto 80-20 rule. Now, the pre-built AI services, whether it's in text or computer vision or language understanding, usually it will fit, 80% of your business scenario needs. However, you're going to find that there's still another 20% of business needs that might not be filled by some sort of pre-built model or those cases where you're going to need something a little bit more custom to you. In most cases, you will find that there's already algorithms, there's already models out there that you can use that cover most of the things that you're trying to solve for. But eventually, the more you do this, the more mature you get about the whole process. And suddenly you find yourself in a position where you need to do some custom stuff. So that's kind of where Talen Traders is now at this point. And in many cases, I might want to start with cognitive services because it really makes it easy to get started. And then that enables me to focus more deeply on the 20% of the scenarios that I can't reach with just your basic out-of-the-box cognitive services. So let me give you a quick example in a demo. If we take the text analytics API that we saw here, and we back here in the text analytics that we saw here, and we so what if we tried another, where'd it go? I keep losing it. What if we tried something else in here? What if we, first of all, accidentally had a typo? Give it some weird stuff in here. What if someone just had some bad handwriting per se. And they still submit this as feedback, whether, it's not impossible to understand what this feedback is, but we got to be a little bit more smart about it. So we have to understand that if we don't do something about this type of feedback that we might be getting, whether that's just filtering out things we can't understand or whatnot, then it's going to throw off everything, because you can see it's giving us a negative sentiment here. And there was nothing negative about that at all. It's just got a couple of really bad spelling errors. So that's kind of the one thing that I wanted to show you. All right. Now, what is Azure Machine Learning Services? What Azure Machine Learning Services is, it's a set of cloud services and APIs, as well as a Python SDK that enable you to prepare your data, build your models, train the models, and then manage them, as well as the different experiments that you're going to be using to build out those models and then finally deploy them at scale. So as the Azure ML services are broken up, there's a few different sort of key artifacts that I'd like to show you. We have the models that we're going to be building. We have the experiments and how we come up with those and develop them. The pipelines that allow us to take our experiments and build the pipeline for the deployment. This is especially useful for linking out the data to model development and redeployment. And then we have the compute management, which allows us to manage compute at scale, creating clusters of VMs as needed. There's the image management, which allows us to manage different environments for our models and deployments. This also allowing us to deploy them on edge devices, as well as on the cloud or even on-prem. And then finally, there's the data storage, which is also integrated into just the one workspace, which is really nice. Like I mentioned earlier, you don't have to dance all over the place and hunt down your different things. They're all just kind of kept in one place. Before we get started with any custom machine learning project, though, it's good to have a good baseline. I think a baseline is very important, especially for a company like Talen Traders, because a baseline enables them to estimate the results before they just go in and grab the state-of-the-art buzzword model and then put it into production. Azure's AutoML service enables you to real quickly get started with building baseline models without even having to write a single line of AI code. And it works kind of as is. So it works as follows. If you provide your data and the task that you want to accomplish and the constraints for the task, it will do it pretty much, it will identify patterns from your data, and it will try to apply them to many different models and train these models in parallel. And then it will return the best baseline model for your task given the constraints. Then you can get started with that model in production and improve on it later. So let's actually take a look at a demo of how we can create that model. And to do this, the first thing that I need to do is I need to go to my Azure ML workspace. First thing you need is I'm going to upload some data and kind of go from there. Okay, so I'm over here in Azure's machine learning inside of my workspace. These are all things that you can deploy right from within Azure and immediately, kind of spin those up and create these whole environments just with a few clicks. It's awesome in terms of just having something at your fingertips. So I'm gonna walk you through the process of like just what we talked about. We go through and we need to create our data set. We need to prepare our experiments and then build out our models and all that kind of stuff. So we're going to start at the very beginning. So the first thing I'm going to do here is I'm going to show you how to create or add a new data set. Now I've already got a bunch of data sets in here because I've been, of course, running different experiments to show you be able to show off a few things within here. But if I want to do a new one, what I would do is I'll come in and let's say I've got my data set stored. In my case, I'll just choose a spreadsheet that I've got locally. So I'm going to do local files. Give it a name, and then I can add some descriptions here if I'd like. And then it's already got some data stores set up from when I deployed this whole thing and set all these things up in here, but you could have multiple created data stores. I'm just going to go with the one that's there for me by default, and then I'll browse out and I'm going to find the spreadsheet that I'm going to be uploading. This is my data set. I can now hit next. You can see it upload. Doesn't take very long at all. It's not that large of a file. Now it's going to give me just a little bit of a sort of view that you can see, like an overview of the data that's coming in, and we can see it's got really some numbers of our rows here, just some text in here, and then the ratings. All of this I'm going to leave as a default and go to next. It does want to cut out the first one. I'm going to say also that second column was not useful for me either, so let's cut that and let's just keep the last two. Hit next and then create. And now I've got a new data set that I can come in here. And we could even explore it, take a little bit broader look at the data to see what we're dealing with here. But again, this is a pretty small data set, so there's not a lot here. There's only 10,000 records or so. But as you can see, it's pretty simple to upload your data. Now, the next thing that I want to show off is once we've got the data uploaded, we have our data set prepared. Our next thing to do is to prepare to set up all the experiments and prepare everything that gets you through all the way to the deployment. Now, we talked about some of the things that can be automated and how you can leverage some of the aspects of just the platform itself that we already have available to you. And a lot of that can be demonstrated really just by going into the automated ML. So we kind of talk about how we can create these new ones from scratch. Right here, I'm just going to do a new automated ML run. I want to go off my old data here. I'm going to give it a name of 40. And we're going to go with, it was the first column that we want to take because we're going to do a sentiment analysis of this is one of the things we're going to show later. And I have a compute cluster that I spun up a little bit ago as well. So I've chosen that. If I didn't have a compute cluster there, I could have gone in here to create a new compute cluster, and we can see that I've got all kinds of available resources at my hand, at my fingertips. I can go from all the way, very small standard D1 all the way up to these huge ones with 218 gigabyte and 250 gig of RAM. So, but I've got one already ready to go. So I'm going to kick off this automated ML process here. Okay, and while that's running, I'm just going to show you a few things. I'll show you some of the, because this is going to take quite a long time for it to run through all these data and set up these models. So let's look at some of the previous ones that I have ran before. We'll come in here, and if I go into just a previous experiment, and you can see that some of these other runs here, in fact, there's still one running right now. But I can come in and I can see all kinds of different aspects of the runs themselves. If they completed, you can go into the logs. The ones that did complete, you can actually go in and see the snapshots of, let me see if I can find one of those. So here's a good example of one that did complete. And we can come up here and take a look at the snapshot, and this will actually tell you the exact state of the code of what took place when that within your Azure Machine Learning workspace, when that run took place. And so you always have this system of record to be able to go back and say, well, just 3 runs ago it ran, what's the difference now? So you can see that that's how that can be super helpful to you. So I've got what I just mostly want to show you is how easy it is to go in and kick off these experiments and sort of just let all those different things I was talking about earlier, let them run wild, and it will actually come back and tell you, once it's all completed, which models it thinks are the best ones to use and what those F1 numbers are going to be. All right, let's get back to our slides. Okay, so anyway, if you want to see more, learn more about some of these things, this is another sort of short link that takes you into all kinds of really great links about what we're found in our docs about machine learning, about automated machine learning. So I definitely use that a lot for myself to come in and just double check on what my understanding of things are. All right, so now that we have our baseline, I think that's great. Let's discuss some of our more advanced Azure ML services that, that provide a foundation on top of which we can train any models, including some open source models, and then put them into production, and then manage them from there. So some of the stuff that we were showing in the previous demo, which I didn't show a great job of, is when we start to use these out-of-the-box models for sentiment analysis, as we saw for the clothes, you could have a lot of different things shared with you in the feedback, and you're not going to really get any kind of actionable sentiment analysis. You're not going to get anything that you can do anything about, because they said they liked the polka dot pants, but the shoes they bought were too small. And so because of that, you can't do anything with that. So we need to be able to establish some sort of like difference about what's being said throughout the entire feedback, and understand some sort of sentiment for, if not each word individually and where they're placed in context of others, groupings of words. And so that we can understand just, a little bit better, more accurately, what the sentiment is. Because a lot of people will provide, not very straightforward feedback on just one thing. So we need to be able to do something else, because only then is it actionable. Otherwise, we have data, but it's just not something we can do anything with. So, and that's kind of the situation that Talen Traders has found themselves in. So we're going to be taking an open source model developed by Intel AI Labs as part of their NLP, natural language processing architect library. And what it does is it provides us with something called aspect-based sentiment analysis. And before, when we were looking at our restaurant reviews, we got just very simple sentiment average for each restaurant, based on just very simple things. However, Talen Traders, that doesn't help us actually, go in any kind of, and like fix anything. Like I said, it's not a very actionable thing. So because they still have one more step that they have to do, they have to send in an inspector who can actually quantify and see why sentiment is so good at one branch versus another. And aspect-based sentiment analysis allows us to address this challenge. So you don't have to have that sort of extra step or extra person going to go inspect things. What it does is it takes our text and it extracts what's called a lexicon from it, of both aspect-related and opinion-related words. And each of those aspects represents things we're interested in, like the price of food, the cleanness of a place, etc. And when we analyze it, the actual review, it would give us a sentiment for each one of these individual aspects, which then in turn allows us to provide much more actionable responses from our models. Now, these are the ABSA key messages, or in other words, the aspect-based sentiment analysis messages. Producing knowledge regarding specific aspects hence enables to gain targeted business insights. It's unsupervised, so does not require cost costly manually tagged data for training. It's domain adaptive, which means it produces domain-specific aspect and opinion terms. And these are all additional NLP architect key messages too. They develop low resource and NLP models that require small amounts of training data. So they're already built for CPU usage rather than GPU usage, which is super nice. And this increases the adoption of NLP by developing deep learning based tools that can be used by non-machine learning experts, as you can probably imagine. And then this produces optimized NLP models that are ready for deployment on pretty much any Intel AI hardware. Oops, clicking in the wrong place. All right. So in order to put this Intel model into production, though, we're going to use the Azure Machine Learning Service. And I think it's important to understand how the end-to-end process works from taking a model from open source up to deploying it into production. And the first thing that we have to do is to prepare a data set. Then we're going to choose our experiment environment. In this case, we're going to be using Jupyter Notebooks. And we have to go and train this model and iterate a few different versions. Once we have a model that's ready for deployment, then we need to work on putting the model into production. So that's a lot of things to cover. I'm going to try to get through most of it as cleanly and as quickly as I can. But that's sort of what we're the process. And Azure Machine Learning, you'll see just in the workspace alone, makes a lot of this super easy. You don't have to really think about any of it. And in this session, we're going to be focusing on the experimentation phase. And so, though I strongly recommend that you check out AIML40 session, which is actually going to be talking about the deployment, that's where you'll learn about all that kind of stuff. But right for now, we're going to be just focusing really on the experiment. So when we start thinking about Talen Traders, when they're thinking of how to take an open source state-of-the-art model that it's out there for anybody to use, but they want to put it into production for themselves, they've noticed that they have a bunch of pretty critical challenges. And some of these challenges, if you've already started playing around with AI, these may resonate with you as well. So these are things like being able to manage the environmental dependencies across the different packages and their different versions. It's always a headache. It's training a model with a globally distributed team in a globally distributed company is also kind of a challenge. I don't know if you've ever had to really think of those types of things, but these days we're not really working in a box. There's not just source control and things of that nature, but cross-team collaboration really requires a new approach. And now it's the same thing applies to everything we're doing with machine learning. Managing large data sets and understanding how to optimize the cost for all that, for storing the data and the compute, all of that's something that's we got to figure out what's going to go on there, because we don't necessarily know what we're going to need in all cases. I mean, hopefully we can use the resources we have and be able to scale up as we need them, but we can also see ourselves needing a bunch of extra resources, but not really thinking we're going to need it long term, and trying to balance out the decisions on, does it make sense for us to spend that kind of money on something we don't need, we're not always using. So there's a lot of things that you have to consider when it comes to that, especially with data, where it's all going to be stored and how you're going to compute that, how you're going to run that kind of stuff. So managing that's something that's kind of challenging. Also, in terms of compliance, if you're starting to handle data and you've got users and customers around the world, and you've got things that you need to worry about, in terms of compliance, making sure that all that they are ensured data protection, and that only certain people have access to the data and only just the correct paths to the data. That's something that they've got to figure out. It's just not something they can ignore. When it comes to their getting their business. And then when they build the models, making sure that the models are interpretable in a way that they can be understood. We want to be able to make sure we know how they were trained and how they can be reproduced. And the last real big challenge that they have is then managing all that distributed training. So You're going to see how this addresses each of one of these needs individually. So now let's just dive into the challenge of distributed training. Dependencies, like I just mentioned, dependencies and containers are always something that we have to really figure out how we're going to do this. If we're going to start training all of our data across different time, do this around the clock on whatever stuff we have available, these are the things we have to start thinking about, because dependencies, they vary. They're all over the place. We need to be able to make sure that we can, when we're dealing with this, we have to deal with a cluster of computers with all of these dependencies, and in the environments for each of our nodes, compute scaling, scheduling, distributed data across nodes, how to scale resources up and down without crashing, how to provision different clusters of VMs, and to gather the results without dealing with race conditions, how to secure access to the nodes, making sure that none of our data gets compromised or hijacked. We have to handle these features when run jobs fail, and how to deal with things when there's rollbacks and we have to recover and go through that whole thing, go through the logging. So not to mention the distributed training algorithm itself, there's a lot that we have to consider here. So if you can imagine, for any single company, that can be, pretty overwhelming. For distributed training, autoscaling is something that is supported, as well as open source distributed training libraries such as Horovod, which has already become pretty much the de facto standard when it comes to distributed training. And all of these things are things that we can take advantage of. And I'm providing these links here. These are more relevant docs for just your own convenience. Like I said, you can either take a picture in this now, or you can grab them all later. But it's a really good, useful resource there. Now, when we're dealing with model optimization, we also have a challenge of this idea of distributed hyperparameter tuning. And so what do we mean? What is distributed hyperparameter tuning? Well, what are hyperparameters typically? First of all, when you see a new state-of-the-art model that's been open sourced, whether that's BERT or, in this case, our aspect-based sentiment analysis model, typically you see these models trained on certain data. And then the performance of the models is dependent on the distribution of the data that it's been trained on. And there are a set of parameters that are configured as part of the models that are optimized for the given data set, so that the researcher who is publishing the model can get the best possible performance. Now, when you take these models and you run them on your own data, or you train them for your own scenario, you're going to have a different distribution of data. So those hyperparameters might need to be adjusted. Otherwise, you will see a big gap in performance of your model when you start to apply it to the Talen Traders data, comparing to what's written in the leaderboards or in the papers. Now, this can be a real challenge going through a manual hyperparameter tuning, because typically what we do is we take a data set and we come up with an algorithm. And then we configure these parameters to build out our first model. And then we can change the parameters again, and we can build out a second model. We try to see whether it's better than the first one. And we do this a couple of times. And we just keep doing this over and over again. And then we might get to we might change our model, and then we have to do this process all over again. And you can imagine, you can see how time consuming and tedious and repetitive and really expensive this process can become. So the Azure Machine Learning Service helps you manage this by running distributed versions of your model and allowing you to choose which are the primary metrics that you want. You want to optimize based on the hyperparameters that you provide, and then it provides a bunch of different policies, such as bandit policies or medium stopping policies and truncation policies that enable early termination. So if it sees that a certain set of hyperparameters aren't providing the best possible results, and it'll just go ahead and terminate those, and then run jobs and release those, and then release and then run and reprioritize the compute for the models that are look much more promising, until you find that optimal set of hyperparameters. So it does a really great job of just deciding, these models aren't getting us anywhere, they're not getting any better. Let's just kill them and redirect all of our compute to something that looks like it's going to be a lot better for us. Now, if you want to get started with that, here's the documentation, another place you can take a picture if you like. We'll be diving into this in a second so you can see how some of the services work. When I need to train an Azure ML model, it works pretty much as follows. And there are just a few steps that we need to get started here. First thing I need to do is to take out the code that I have for a model, and it's going to go into model that I have for training. I need to send it into Azure Machine Learning Services, and then the service will then create the configuration and put all that into a Docker image. So it's going to create the configuration for the experiment that I've just sent, and it will create a Docker image, and it will deploy it into the compute target that I've configured, which will be linked to the data that I've uploaded into my data set. Okay, so it goes to my data set, and then it'll be launched. It will launch the training script that I've configured, and then in real time, it will send me back a stream of logs and metrics so I can see the process pretty much as though I was running them on my machine myself, which is really cool. And we're going to see how that works here in a moment. Now there's 8 steps to this whole thing. To take this aspect-based sentiment analysis model into production, we're going to have 8 things that we're going to do. The first thing we're going to do is configure Azure Machine Learning Workspace. We've already kind of talked a little bit about that. We saw that above, and it will act as our central place where we're storing everything, the training models and all that kind of stuff. Then we're going to define a compute target on which our training model is going to run. Then we're going to upload our data set. Then we're going to create the experiment with the training code, encompassing all the different dependencies that we have and the different, all that in the training script. And then the training script can be taken from the existing Intel's code. Sometimes we might need to adjust the training script just a little bit from the original library for distributed training. In other cases, though, changes to the code would be very minimal. I don't think we're really doing much here. And then we're going to run the estimator to perform the training. Once we're done with the results of training, we get the model, which we can then register, get it prepared. And then a registered model can be deployed and tested and becomes all ready and set for production. Now let's have a look at how such a model can be trained using a compute cluster. Typically as a data scientist, I'll do most of my development from a Jupyter notebook, so I can select any Jupyter environment and we'll go from there. So that's where we're going to hop in and take a look in just a few minutes we have remaining and go through our Jupyter notebook so we can see how this can be done. Okay, so I'm in my Jupyter notebook here, and I've only got just a few minutes, so we're going to step through what's happening here. This is just another way for me to, run the exact type of training models we saw earlier, but I'm going to do it from within. Instead of doing it within Azure Machine Learning, I'm just going to step through this notebook here, which allows me to run each command individually, and we can actually do all the same things from right in here. So here's what's happening. The first thing we're going to do is once we prepared a little bit of a workspace for us, we're creating a few resources here in terms of just a resource name, resource group name, what our workspace name is. This is how we get all that stuff provisioned and ready to go. So I would just click run for that. When it comes to capturing the exact type of compute or the compute cluster that we're going to be using, here in this case, we're going to go ahead and create a cluster called ABSA cluster, just aspect-based sentiment analysis cluster. And then we'll pass in a few different variables. We'll change, or we're going to set the size of the VMs that we're choosing here. So I'm just going with the standard D3 version 2. I'm going to choose a low priority. Low priorities will definitely run longer. It'll take longer for them to run all their experiments, but it will save you a ton of money. So if these aren't time-sensitive things, I definitely would go with the low priority. The min nodes here and the max nodes here, this is our cluster. So how many do you want? And if you set it to 0, what happens is it will actually shut down everything once all the models have been run. It will just shut everything down, which maybe you want, but maybe also you want to keep one running so that you can, maybe come back in really quickly and do some more. So those are just some different config changes that you can make there. The next part of the process is that we're going to upload our data. And in this case, we're just pulling some stuff in right out of our GitHub repository. And so it's just taking our different CSVs, pulling those right in. We also use this little tool here called Glove that kind of merges the two names are drawing a blank on me right now. Anyway, pulls down the Glove aspect of this. And then the next part is we're ready to train the file. And this is our train file. It's a Python script that goes through. And here's where we start to tweak or at least change and get things kind of set up for our hyperparameters. So we go in here. It was our aspect threshold and our opinion threshold. Those are the two terms I just couldn't remember just from a moment ago. But those are our hyperparameters. And this is where we would make changes on them. And then for the most part, the rest of this isn't, super necessarily needs to be understood. But we get down here and then we run this thing, and it'll provide us with an F1 weight, which gives us, sort of its prediction, its strength of prediction. And so that's pretty much all that stuff there. And then it goes into creating an experiment. Again, we're kind of keeping the name the same here. We pass in a few different parts of our where we can find the train script, as well as any kind of dependencies, any kind of pip packages that we need. Those all get passed in as well. Then we come down here and we run that again. That part gets run. And then now we're into actually adjusting those hyperparameters. And this is where those types of steps take place within our Python script here, our notebook. Now, what else can I show you? The amount of time that we have here. Once all of these run, once we get kind of work through our Python script and we're ready, we get down here and we see why this particular custom model is a little bit better for us. I loved the sweater, but hated the pants, and has this negative connotation to part of it. But then down here, I absolutely love this jacket, positive. I wear it almost every day. So within just those small changes, you can see it's now giving us something that's a little bit more usable, something that's more actionable. And then down here, this is where we package everything up. We get the configuration of the environment all set. And then once we've completed all that, we package it all up, and it's ready for our deployment, which will be what you'll see in AIML40. All right, so let's come back to our slides and wrap up. Well, we have what we have here. So let's tie this all together. We've gone through and reviewed the main industry advances in AI. We've talked about where things have kind of advanced recently. We've introduced cognitive services, and we went in to use those, observing that 80-20 rule, and how maybe something you've got a really simple use case, and you're in that 80 group, and you should definitely go check out what it's already there. We also went in deeper dive on building custom baseline models using AutoML without needing a single line of machine learning code. And we've trained a real-world open-source aspect-based sentiment analysis state-of-the-art model with NLP architecture using distributed training and hyperparameter tuning. That's what we did when we were going through our little Jupyter notebook there. And then we actually put that model to work so that we can carry it out. And hopefully, in the next section, you'll get to see how you can deploy that out into your production environment. So with that, I think the takeaways here, I hope you take home, is first of all, AI is instrumental in companies' success in the modern world. That's just the facts. And most of the AI can be incorporated into production using cognitive services. There's already a bunch of stuff there. It's simple to use. And I bet it can take care of about 80% of the use cases you have. However, for the more complex tasks, Microsoft provides both simple codeless ways to train a baseline model, as well as sophisticated ways, a very sophisticated machine learning service that can actually just simplify the whole process for you, which makes the lives of your data scientists very, very, very happy. And then whether you're experienced ML professional or traditional developer, we've got you covered. We've got everything that you need, and you can kind of just dive right in. And a few more docs here. Here's some other great resources I suggest you check out just to kind of get your head around a lot of the things I've been talking about today. There's a bunch of great Learn courses, modules you can take as well. And don't forget about the certification that we're doing here, as well as our last session of the learning path. So with that, thank you very much for your time, and we'll see you again later.